All right, so it's 11:30. We'll get our late morning session going. Good morning to everybody. My name is Anna Caesar. I'm the Aquatic Invasive Species Coordinator with Golden Sands Resource Conservation and Development Council. I'm going to be the moderator for this Central Wisconsin session titled Improving Water Quality in the Wisconsin River Basin, Past, Present, and Future. We have two presenters for this hour-long session. If you have any questions for our presenters, please type them in the Q&A box. Do not type them in the chat box as we can't see them on this side of the presentation. With that, I'd like to introduce our two speakers. Pat Oldenburg is the TMDL, or Total Maximum Daily Load Coordinator with Wisconsin DNR, and Scott Provost, the Water Resources Specialist, also with Wisconsin DNR. With that, I'll leave it to Pat to take it away.
All right, thanks, Anna. I guess, so as Anna said, I'm the TMDL coordinator for the Wisconsin River. And for those of you who aren't familiar, the TMDL, or Total Maximum Daily Load for Wisconsin River Basin, covers a pretty wide area from the headwaters of the river up in Lac Vieux des Airs, all the way down to the dam at Lake Wisconsin, down by Saukville, Sauk City area or Sauk Prairie, I should say, area down in down by Columbia and Sauk counties. So about 9,000 square miles. But for today, I want to focus a little bit, kind of have a fairly narrow focus, looking at one of our long-term trend monitoring stations on the river, and then also what we've seen for changes in lake water quality on the Petenwell Reservoir. So Wisconsin DNR maintains a pretty broad network of long-term trend monitoring on our larger rivers. And basically what we're doing through that is we're capturing water chemistry at these various 4 points around the state and trying to get a real good picture about what our long-term changes in water quality are throughout the state. And we've got 3 sites on the Wisconsin River, one at Merrill, one at Basin near Wisconsin Rapids. We also have a site at Wisconsin Dells and at Muscadet. And in addition to phosphorus, which is what I'm going to be talking about today, we also monitor a large number of other parameters, things like nitrogen, chlorides, suspended solids. So we get kind of a good broad picture about water quality changes over time throughout the state. Like I said, I'm going to focus on the site up at the Basin Dam. And in terms of phosphorus monitoring, we've been monitoring that site since 1977. So pretty long data record there. And likewise, we have a adjacent flow monitoring station at Wisconsin Rapids. And that's also been running for a long time. I believe, yeah, something on the order since like the 1914. So what we do is we go out and we capture monitoring data at that site, water chemistry data, every once a month throughout all that time period. And if we start looking at our last 20 years, and again, focusing on phosphorus, we've seen that by this blue line on the graph here, that our average concentration has been declining. Prior to this monitoring period of 2000 on, it was averaging around 100 to 120 micrograms per liter total phosphorus. Just as a kind of a reference for our large rivers, we want to see those rivers below 100 micrograms per liter. Obviously, when we have large reservoirs on a system, we need much better water quality in those reservoirs. And so even if we're meeting our river criteria, we're going to have serious algae issues in those reservoirs because of that amount of phosphorus. And that's what we've seen on our large reservoirs, Petenwell, Castle Rock. as prime examples. So, we've seen this this decline in phosphorus over the last 20 years. We've also seen a lot of variation in flow, and the previous presentation on the little plover really touched home a lot of those issues that we saw in the early and mid 2000s, and we saw those basin wide of low water levels, and that was kind of I'd say pretty close to I think we could call it an unprecedented extended period of drought for this system, at least from what we've seen over our period of record, which stretches back to the beginning of the last century. So on average over that time period, we're around 5,000 CFS, cubic feet per second, and we were well below that during the early 2000s, and now as you all know, it's been raining a lot the last few years, and now we're well above that. Some of our our highest sustained flows we've seen throughout this period. And so those changes in flows have an impact on water chemistry. Certainly a lot of other things impact water chemistry, but flow can be a major driver. And so what we do with our data is we start to look at that relationship between the two. And really what that gets us to is our loads, our loads of a pollutant, and that's the total maximum daily load, TMDL. We start thinking about, okay, how many pounds of phosphorus is coming down the river on a daily basis. And the way we figure that out is we are very good at capturing our flow data. Almost, we can get a level recording every 15 minutes. That level recording of the river relates back to what we call a rating curve, which is a series of flow measurements. So we know essentially when the river is at X number of feet, that means there are Y CFS of cubic feet per second of water moving by. So we get a very good picture of the water balance. When we get to our chemistry, in particular, looking at these long-term trend sites, we can't go out and we can't collect a water sample every day. So what we do is we collect our monthly water chemistry over this long period of time, and then we use regression tools, regression models to really estimate what was happening on the days we weren't there. Because concentration really ends up being a function of the river flow, the year in terms of trends, and then also the time of year is very important. And so we do that exercise, and the resulting graph is what you see here for the site at Basin. And what we can see is there's a big variation in the amount of pounds that come down any one year. And not surprisingly, that's what a lot of that can be weather related, but there's a lot of other things going on in the system that can affect that. But when we start thinking about what this load's doing and what these weather effects are, what the other effects are, one of the ways we can tease out some of that information is to start looking at, well, how is that phosphorus concentration based on, relating to that flow? So what we do is we calculate what's called a flow weighted mean. And basically that's just the total load, how many pounds came down that year, divided by the total flow that came down that year. And that's another way that we can tease out some of this information and really narrow things down. And what we can see from this graph is this lighter blue line shows that flow weighted mean concentration has also been going down over the last 20 years, just like the raw concentration data. So again, it points to us that yes, water quality has improved in terms of phosphorus in the Wisconsin River over that time period. And we start to, we say, okay, there's been an improvement. We start to ask ourselves, well, what's changed? Well, one thing we do know that's changed is there's been a tremendous drop in our point source loads in the Wisconsin River Basin over the last 20 years. It's like a 70% reduction. And what this graph trying to represent is how that proportion of that total load that comes by the Basin station, how much of that is likely due to point sources, how much is likely due to other sources. Now, this is a pretty simplified way of looking at it, really, because we can add up how many pounds came out of the point sources due to the monitoring that they're required in their wastewater permits. And then we're just in this case, just simply subtracting it, just to get a feel for how those things are, the relative differences, the relative impacts. And what we see is, yep, those are going down, and it appears that may be one of the drivers to this reduction in phosphorus that we're seeing in the river. The kind of the regulatory thinking about how that happened is in 1992, Wisconsin passed our statewide phosphorus rule, effectively, or to say in general, mandating about a 1 milligram per liter phosphorus limit. Now, there were some exceptions to that rule and so forth, and implementation took time. And that's one of the reasons why we see this kind of this declining trend over this time period, is that as that rule matured and more facilities were brought under it and improved treatment, we saw this gradual decline in phosphorus over even over that last, particularly over that kind of the beginning of this time period, over the early to mid early 2000s through 2010, 2012. We've also lost a few of our mills along the way. That plays some role, but probably lesser extent than just the improved treatment at these facilities. So, but what we see is, obviously we still see a lot of bouncing around in that total load that's coming through. And really what that goes back to is weather. And it's, how wet is it? How much rain are we getting? We see, as we see on this graph, the black line representing that mean annual flow, that you can see how that close relationship to the amount of flow that we get down, that comes down the river, and the amount of phosphorus pounds that we get. And a lot of that comes back to just, that's the way watersheds work. It rains, the rain runs off, it carries some soil particles with it, it carries some dissolved phosphorus with it, and hence the increase in loading. And we've got a lot going on in this watershed. It's a big watershed, and a lot of changes have happened in agriculture over these last 20 years. We've seen tremendous changes in the way we're growing our crops and what crops we're growing. We've seen a lot of loss of our hay in our rotations over these years, and more row crops, more corn, more soybeans. And what that does is you tend to get more erosion because you're disturbing that soil through tillage when you're growing corn and soybeans. Historically, we are getting better on our tillage. We're not tilling those things quite as intensively as we may have done 20 years ago. So it's kind of a stalemate right now, I think, is what we're seeing. We're seeing these changes in ag that were kind of to the negative early on, where we're losing these hay rotations, and now we're seeing some of that's coming back. Certainly, we're seeing, push for more diversity in our cropping systems, big push to no-till cover crops, things like that can, really reduce those losses off those agricultural fields. But we're kind of in early days of adoption there, I'll say, in many places in our watershed. So we haven't really, I guess the long story short, we haven't really picked out a big trend yet in those non-point loads, other than when it rains, we get more losses. So that's kind of the river picture. And, so the river is obviously doing better. But, one question is, well, how does that relate to the lake? And again, this is another case where it's really nice to have these long-term data sets. And this long-term data set is the result of our folks who work with our Citizen Lake Monitoring Program. These are the citizens on the lake doing the monitoring, and I just want to thank them again for the effort that they put in over this time, not just on this lake, but on lakes throughout the state, because it really does become, these data sets are really great for looking at some of these long-term issues and really being able to understand the changes that we see in lakes throughout the state. So the site that's been monitored on Petenwell is kind of right in the middle of the lake, maybe a little bit further in the upper half. And that site has been monitored continuously for Secchi depth, measure of water clarity, since 2005. And since 2007, it's also been sampled for total phosphorus and chlorophyll, or a measure of algae density. And that's been going on for a number of years also. So again, what that allows us to do is really start looking at how the lake has changed over time. And the things that we've seen over that time period, that last 15 years ago, is we're seeing a drop in the in-lake phosphorus and in-lake chlorophyll levels. So we're seeing, we're seeing a response in the lake to these changes that we've seen in the flow weighted mean and phosphorus concentrations in the river. Likewise, our water clarity is improved, and that's because we're getting less algae than we were before. I mean, we still see algae blooms out there that can be very significant, but they do not appear to be as intense as they had been in the past. And so another way that we can look at this data is we can do some transformations, and this is what we call a trophic state index, or TSI value, and it really gives us a way of relating these two things to see how they are interacting and behaving. And again, what we see is they're all behaving consistently. We're seeing reductions in phosphorus, which are leading to reductions in algal densities, which is then resulting in water clarity. I mean, that shows that, yeah, phosphorus is our main driver out there, and algae are really what are driving our water clarity issues. So, we're seeing the river improve, and we appear to be seeing the lake improve. But we still have a lot of questions when we look at and think about this data. One question then in my mind is, why does it look like the in-lake phosphorus is reduced so much more than the river? Something we really need to think about and maybe look more closely at. But my working hypothesis is a lot of this has to do with the flows that we've seen in the reservoir. We had that drought period in the early 2000s, and now we are seeing much higher flows, and it's pretty likely, based on the characteristics of this lake, that what we were seeing, one of the things that we see under those lower flow conditions is we see much more opportunity for some phosphorus release in the upper half of the reservoir, which is really what we call an internal loading, and that allowing that to that phosphorus that's in those sediments to resuspend or recycle up into the water column. And so, but that's, it's still only a portion of what's driving the system. Really, the dominant driver is what's coming down the river on a day-to-day basis, and that's really where we need to focus our energies and kind of reducing that. And so, the one question is, well, are we going to see more reduction from our point sources? And I guess what I'm saying is we're going to see some, but nothing like we've saw over the last 20 years. A lot of our facilities are at the point where they're, very close to or below their allowable discharge limits under the TMDL. Certainly, we have some that are over, and then we have some that are well under. But as a group, we're kind of very close to that, total amount of phosphorus from the point sources that are allowed. So we'll see some reductions, but they're going to be minor. And so that leads us to really the kind of the tougher nut to crack, and the thing that Scott's going to be talking about next, and that really is those reductions from our non-point sources. The one question we get asked a lot is, well, when will we be able to see that happening? And it really comes right back to how fast are those practices adopted onto the landscape. We've looked at this issue with the point sources. We started with a rule in 1992 about how much phosphorus those facilities were allowed to discharge. It took a long time to get that fully implemented, and we saw that still seeing those reductions throughout the early 2000s. And that's with a regulated a permit from DNR. So when we're talking about these largely voluntary efforts, it is going to take time to bring that in, but there's a lot of exciting things happening in the basin, and we're really seeing folks step up and do those things. We heard a little bit about it this morning with the little plover. We're going to hear a lot more about it this afternoon. And so, we're going to, those things are happening, but, the way I look at it and when I look at the data, I think one thing we'll see is when we start seeing those changes on the landscape, recognizing that people are, farming differently than they were, either now or 10 years ago. That's when we'll probably be seeing it in the water. Really that kind of that big scale change to say, hey, things are getting better on the land, and we will see it in the water. And with that, I think I can turn it over to Scott.
All right, just give me a second here. There's my little box. Can you see it now, or which one do you see?
We're not seeing it just yet, Scott. Are you sharing your screen?
Yeah, I'm trying to. Anything yet?
No. Did you click that share screen icon down there at the bottom? There it goes. Oh. Nope, not just yet.
Yeah, I thought I did that. You're not seeing nothing, huh?
Nope.
Might
Try
have to
clicking
take-
that green icon one more time.
Oh, I think I got it. Is that working now?
Yep, there you go.
All right, and now you're seeing the whole screen?
Yeah, so you want to throw it into presentation mode.
All right, bear with me, folks. Bear with me. There. Now what do you see?
Still seeing the original mode.
Come on.
Try clicking that from beginning button again.
I think I had two of them open. That's what's happening here. You might have to take control here.
Hey, Scott, if you go at the bottom of your screen in the very lower left, yep, right there.
Yeah, I tried that, and then.
Oh, okay.
Do you have it now?
No, that's usually what I do. That's the button I click. Try, Pat's suggesting, why don't you unshare your screen? Oh, never
there
mind.
it goes.
Yeah, all right. Just got to keep clicking them all. Something will happen. So sorry, folks. Thanks, Pat, for leading us into this discussion. This is how we work over here in the West District. Pat's kind of like the Wile E. Coyote. He's the super genius engineer guy. He's usually multitasking, giving lunch and learn presentations to the International Space Station and working on the TMDL in the spare time. So you need that kind of a background. You need that technical expertise for a job as big as what he has. In fact, when I applied for his job and lost to Pat, my boss called me up and said, yeah, we gave it to Pat. And I said, look, you gave it to the most qualified guy. So you got to have that kind of technical ability. And that's a full-time job in itself. When you work on a basin this large, he's addressing an area that's 21% of the state. That's geographical area. That's the land and water. And then, I kind of go around and just talk about the stuff and try to get some folks interested in doing things. So you've heard this ad nauseum for the last couple of days, watershed. We're going to use this in a hydraulic sense or reference. Most of you know what it is, but if you don't, it's not a big deal. I had explained it to my mom when she asked me what my major was in school, and I used a salad bowl. And this, what we're going to, if you look over here to the left, it's pretty much all the land that drains to the smallest little tributary all the way down to the big major river stem. It includes the groundwater. So even though you're up here on the land, you have an effect what happens way downstream. So what you do in your backyard today, once the ground thaws, it's going to ultimately end up in the Gulf of Mexico and every water body in between. including Petenwell, Castle Rock, all the way down. And our biggest basin, or we're talking about the basin scale. So when you get a bunch of watersheds together, and one big one is a basin. A basin is just a big watershed with a bunch of little ones in it. And the other thing, whoops, here's what you got to remember. And this goes for everybody. I don't care what field you work in. If you work with me or you're working on the other side, water quality starts on the land. It doesn't start in the lake. It starts on the land. It could be miles away. And it doesn't matter if you're in a type of watershed there's lots of influence, or in a forested watershed where there's not. That what you do in that watershed or on that land is going to affect the water quality. So this is the stuff that Oldie gives me, and he cranks all these numbers out. But to put things in perspective, in this Wisconsin River Basin, there's 21 counties, 85 cities and villages. You need not all of those, but most of them have some type of permitted wastewater facility. Those are point sources, and we'll get in that in a second. Sometimes there's things such as permitted MS4s, which are basically for stormwater for municipalities. How you're going to manage the stormwater, that's relatively new. For years, all the drainage water from a parking lot or something went to a pipe that went to the river straight in, or into a lake straight in. It did not go through any type of treatment. And there's 14 active citizen groups. That's the key, folks. That's how you're going to get things done. You got to go. The TMDL that Pat was talking about is a tool. It's a tool to use to get things done. Nothing happens without implementation, and implementation doesn't happen without people. So if we get these numbers from Oldie, that's Pat Oldenburg, by the way, folks. Sorry, but if you look at what he's been able to calculate, this big red circle down here, that's the type of land use and type of source that we're getting most of our phosphorus from. And that would be called non-point source. And if you look over here in the dark purple, this is like your wastewater treatment facilities. That's what Pat was talking about. And if you look at that width down there on that graph and compare it to the green, that's your background. So yeah, it's above background, and it's doubling the background effect. But look at what the non-point source is bringing in. This is our big guy right here. This is the one that's providing most of our phosphorus into the system. So when you're working with these, you got to think holistically, and you heard people talking about that as a common theme throughout this conference. You got to think and work as an ecosystem does. It's a 3D matrix. It's like, remember the Rubik's Cube? Some of the youngins that work for us now probably don't, but when you move one side, it affects two others. So it's a matrix. You move it around, it has an impact that you don't even realize sometimes. So that's how you got to think. It's not an A plus B equals C situation out there. So, but you can maintain that thought, but you can start out by working small, because it's all connected. And if we just if we embrace this holistic thought process and employ that in how we, even on the smallest scale, we will get to our result. And to do that, just commonly what I tell people is work small and think big. There's all kinds of little opportunities here and there to fix on the way. It could be a stormwater area, or it could be a non-point source area that can be solved by a barnyard type thing. There's all kinds of little projects on the way, and every one of those works. The old cliche my predecessor used to say is, eutrophication in lakes is usually a result of a death by 1,000 cuts. So there's a bunch of little stuff working in concert. So you just got to fix them on your way through. And you got to work together, and you got to grow together. This is huge. And on this case, these are some street volunteer monitors I used to work with a long time ago. They're from all different fields. One of those guys, without naming them, was a multimillionaire. The other ones are just trout enthusiasts. They don't care. They're out there for the common cause. So, and as they work together, they're learning things together. And when you get into this, you get all this data and this TMDL, and we want to know what you're going to do with it. you got to know the players. We go back to that graph that I was showing you before. If we got point source and non-point source people. So thinking holistically, we got to include them all. So the point source would be the stuff, your pollution that comes right out of a pipe, like a wastewater treatment plant, or say something like even a hose from a herbicide application, anything like that is a point source. Then your non-point source is the water that runs across the land and it gets into the river system that way, carrying soil particles, that carries nitrogen, carries phosphorus. And what's in the middle is everybody here. This is a older photo of the Packers Group, Petenwell and Castle Rock stewards. I think that formed sometime in 06, 07. Had my first phone call with Rick Georgeson, who now has become somewhat synonymous with collaboration between lake folks and farmers. And that's how you got to bring everybody together, and you got to bring all those stakeholders together, not just the lake group, not just the A group, not just the municipalities, the point sources. You got to bring them all to the table. So briefly, we're just going to go through the point source pollution because it does play a role. And as Pat pointed out, there I'll show you this graph in a second. It shows that it is working. This was authorized under Clean Water Act 1972. So it's been around for about 50 years. Prior to that, a lot of city sewers, paper mill sewers and things went directly in the river without any treatment at all. Growing up on the Wisconsin River, I remember foam up to 4 or 5 feet high, just all the way across the river in rapids, in Wisconsin Rapids. That was in 74, 75, but it was it took that long before you even started seeing anything benefits out there from the Clean Water Act. That's all. EPA authorizes the state of Wisconsin to do what they call WPDS, or Wisconsin Pollution Discharge Elimination Systems permit, that so we enact the Clean Water Act. Other states, more so in the South, do not. So the EPA manages their water resources. Wisconsin, we have the individual permits in Wisconsin, general permits, stormwater permits, and for CAFOs, that's confined animal feeding operations, to be on your lower right here. The stormwater permits that go in, those permits aren't there just because we want to control things. It's there to try to reduce the amount of nutrients coming in. So we look at point source management, and like Pat was talking about, this is your estimated annual phosphorus loading to Petenwell. He gave it to me some time ago. But if you look at here in 1993, you're at 700,000 pounds. And by 2007, this trend is still going down, by the way. They've cut that almost in half. So when you go back to that original graph I showed you, that the point source was so much smaller than non-point source, because we have the Clean Water Act that specifically gives us authority to work with point sources. So there's more regulation there, and the point sources really take on a brunt of the reduction of phosphorus out there, but they can only do so much. After that, it takes more. That's what brings us to non-point source pollution. This is the biggie. It's also the most challenging, because there's the whole premise of non-point source. It's not coming from a point, it's diffused, it's coming from all over the place. So as you can't point to a pipe and say that's where it's at. It could be coming from one field, it could be coming from another field, it could be coming from a parking lot, and it all comes together. That's non-point source. And if you look at the map on the right, you'll see central Wisconsin here. There's a lot of high vulnerability for of our watersheds for non-point source pollution. And that's the driving force of what's happening in the Wisconsin River TMDL. So in order to address the non-point source management, or address non-point sources, you have to do that with people. We don't have the same set of regulations, the same set of rules for that. Whoops. So it includes all of these. You get this kind of runoff over here to the right. You get some fertilizer application. Once it gets past the root system, it gets in the groundwater and out to the nearest stream, which goes in there. I could show you pictures of treatment of stormwater sewers. I can show you pictures of parking lot with oil. And if you did a chemical analysis of that water, you'd find a whole bunch of high range of organics molecules in there that aren't good for you. You'd find heavy metals. So it's just not ag, it's everything. It just happens to be a lot more pictures out there with this. Traditional watershed management usually focused on in situ soil. That means soil in place, like right here. This is what we're going to manage right there, right here. We talked about soil fertility and nutrient uptake and crop need. And that's what we managed for. We didn't manage for groundwater or preventing overland flow. If we did, it was always with hard practices, meaning concrete barnyards or something like a buffer strip or something like that. And those work, but they only work at that point. So you got to think bigger. What we didn't concentrate much on the type of fertilizer. Is it commercial or is it manure? Commercial fertilizer is like ammonium nitrate is it's all in organic form, so the plants can take it up right away. It's widely available, it's used, but it also converts, that's also a major source of nitrate contamination in groundwater and surface water and essential sands. So they would be better off using manure in a lot of cases, but the local or the citizen input on that, or the citizen view of that is not always very good. Nobody likes seeing that stuff pumped out or even smelling it. So there's all kinds of trade-offs. We never considered the depth of groundwater either. So we just applied all the chemical we needed, all the fertilizer we needed just to maximize plant output. Then we had wind erosion. That wasn't really thought of too much. It's kind of hard to control, and it's getting worse with climate change. Climate change is driving our non-point sources too, but what we're going to talk about here shortly is how we can cover all of this. So there's so many challenges, but this is how you get it done. You got to partner, you got to find people, you got to have boots on the ground. You don't do this by sitting at a desk. You got to get out, get people talking with each other. That's how you get results. So it's all people all the time. It's farmer-led councils. It's TMDLs, 9 key element plans, watershed management groups. Instead of just a lake group, think about a watershed group. Riparian owners, the people along the shoreline, they're usually the ones driving or taking the first steps because it's their backyard, their lake they're seeing this, if there's algae blooms or whatever, they want to do something about it. And they realize you can't be reactive and treat the algae bloom with algicide all the time. You got to do something to cut the source off. And that's part of, you might have heard integrated pest management from the APM talks. This is part of it, integrated pest management, controlling the nutrients that's causing the problem. Municipalities, those are partners. If they got stormwater, other agencies, there's Department of Ag, Trade and Consumer Protection, your local county LWCDs, land water conservation departments. That's your number one contact, at least for mine, for getting boots on the ground. They know a lot of the egg producers. They know the area really well. And there's a rumor I heard that some people don't like DNR. So sometimes it's good to have somebody else come out and talk to somebody to, kind of get their attention on what's going on. And it takes you and me always. And one of the ways to get there, another watershed approach is, part of a TMDL, doesn't have to be a TMDL, but it certainly helps, is to have a 9 key element plan. I really like these. And I like these because it actually has an implementation schedule, meaning we are going to do this such and such thing by such and such date. All your TMDLs, watershed management plans, lake plans in the past, they didn't always have a good implementation schedule. It was a how-to manual. and it never really got implemented. So some of those reports are pretty expensive, and they just sat on a shelf. They didn't get implemented. 9 key element plan requires implementation. If you don't implement, you got to explain to the EPA why. This is, and what these are is they target smaller watersheds, like you'll see with these little yellow hash areas, and they work at a much smaller scale on the land to reduce nutrient input. So this again is a watershed approach using land management to get your water quality goals. Here's another excellent one. These are farmer-led watershed councils. They over by the St. Croix and Red Cedar areas where they really got their first start in Wisconsin, and they just done an enormous job over there working with, and it all started with the local folks, you know, and that's where it comes in together, is people working with people. It's that people thing again. You got to keep working together to reduce the phosphorus input from ag, from municipal sources. In this case, it was mostly ag. And you look at some of the stuff that they developed is when they work with it, it builds that relationship, like Rick Georgeson has done in the past, and like 14 Mile Creek Watershed has done in the past. And a big shout out to that group. They're in 3 or 4 short years, they're reaching out into the growers and the producers out there, taking a proactive approach. And I got to give a lot of credit to Don Easted for pushing that along. And then there are a huge group of folks in the background, John Andrezzi and Karen Kanoktik, that are all working behind the scenes too, that make this happen. So you might only, you know, it kind of reminds me of the tip of the iceberg. There's a few people, but then underneath that, there's just a huge group of people working on everything from farmer-led watershed councils to watershed groups. And you always got to choose your leader wisely. You know, sometimes you get somebody that's just a go-getter and is a doer, but it's not a planner. I'm not an organized person. I'm not the best one to probably keep everything straight and bills and receipts. That's what my wife does for me. Otherwise, I would be in trouble. You know, so I wouldn't be a great leader for this, but somebody who can keep a track of those, of all the little details, knows how to motivate people. That's a good leader. Watershed groups is another one. Usually they start out as a lake or river association, but the Lake and River Association has an aha moment and they say, hey, look at upstream here. This is 14 Mile Creek Watershed. And most of the land use up here is in agriculture. There's some prairie chicken land and grasslands, and then it's highly residential, intense residential area along the lake. And coincidentally, this intense residential area kicks out just a little less than half of the total load coming into these lakes. The rest is coming from up here. So the folks at 14 Miles said, hey, we got to do something. We had several years ago, somebody's dog died from a blue-green algae bloom. There were some sick kids. You know, we were running down there sampling for blue-green algae blooms, and an old, again, you know, there's an old cliche, never waste a crisis. So these folks got together and said, hey, we got to go bigger. We got to go better. We got to fix this and fix it the right way. So they formed I think it was 14 Mile Creek Watershed Group at the time, and they just started looking broad scale and everything. Now they're transforming them to a 501c3, 14 Mile Creek Watershed Alliance. They went through the whole maturation process to where they are today. So I give them huge kudos for how far they come in such a short time. But that's what happens when you start thinking holistically or as watershed size, because you're understanding that, hey, I live right here, maybe or where the two lakes come together, but somebody up here, if they improve their water quality, it's helping me. So why wouldn't I want to help them? So it's a give and take. You're helping me, I help you, kind of thing. That's how we get this done. You know, it's working together, and again, choose your leaders wisely. I can't emphasize that enough. And does a holistic approach work? So here's a perfect example, folks. I'm going to use this group right here on the Wisconsin River. started with Packers, and Packers gets talking with the old Plain folks up there, way up in the watershed, 50 miles away. But they know that Packers, after working with TMDL coordinators like Pat, said, hey, we got to go up in that watershed. And then Mill Creek is like works with 14 Mile Creek. They get introduced from Packers. And it's like this domino effect, but it branches out. And then pretty soon you go from Packers, the 14 Mile, Epic, the Mill Creek watershed folks, and now you bring it into the agencies, or not the agencies, but the land use, the Potato Vegetable Growers Association, Wisconsin Wetlands Association, then the different agencies, and you all work together, and you start getting out the message of good soil health practices. And this is what you get. You get a 28-year-old farmer up in towards the Athens area who manages a 5,000 acres of crops, 2,800 head of dairy cattle. This is his presentation. And he's learned this because of groups like Epic and working with all these agencies and everybody together. He's doing they're doing as much no-till as possible. And he said that he wouldn't go back to not doing no-till because it saves them money. It increases, they utilize cover crops, and they incorporate, and this all helps in their water saving practices and nutrient management on that farm. It keeps that nutrient in the soil, not in the water. They're responsible and productive manure use and handling. They're in a rural area that can do it easily. It helps them. They work that right into their planting schedule, what they're going to plant and everything together. And in that land that was unproductive for them, that when they start looking at the yields per acre in a certain area, and they find out, you know what, I'm losing money farming this spot. So what I'm going to do, I'm going to take it out of production and I'll turn it into hay, and we'll manage that area for hay instead of corn or soybean or whatever. Now that soil's locked in and it's better use for that land. He's not plowing as much. He's not wasting resources on it and saving him money. So does a holistic approach work? Yeah, there's my most concise slide I've ever done. So what, and this is important, folks. So what doesn't work?
Hey, Scott, real quick, you've got about 4 minutes left.
All right, thank you. I'll be done by then. If you think you're going to regulate your way to your water quality goals, it's not going to happen. Especially now, we got about as much regulation as you're going to get for a while. We could tweak some things here and there, but that's like putting a speed limit sign up everywhere and having one state patrol agent per county or per state. Even if there's nobody there to enforce it, what good is the rule do? And if you're going to enforce it, how are you going to enforce every farm field out there? Even if you had one person per county, you're going to have them out there on every rain event monitoring the edge of field? Probably not. Or monitoring the stormwater outflow? Probably not. Another thing you don't do is you don't go out to a multi-generational farmer and say, hey, this is what you guys need to do. You're going to get hit instant. If they don't laugh at you first, then they're just you just shut it down. The conversation's done. They're not listening to you anymore. Because then you get to a point where you're talking to somebody rather than talking with. And that's important. Hearing, but not listening. Folks will, yeah, I heard you, but you don't even, you heard it, but you don't register. You don't think about it. I was notorious for this. It took me years to figure this out. Not funding the boots on the ground needs. If you're not funding those folks to get that message out, the message doesn't get out. So you can't just say, oh, we're going to fund hard practices. Great. Well, what good is that if you don't have anybody out there trying to recruit somebody to do hard practice? Because this is mostly volunteer. Why wait for a violation that would force this? The needle's in, damage is done. Let's be proactive and get out there and get those folks out there to talk about good things like this previous farmer was doing here. This is soil health. Everything comes down to it. Goes back. Your water quality starts on the land. Soil health is the key. And you saw that earlier today in that presentation from Judith Schwartz. That's soil health she was talking about across the globe. They're doing it everywhere. We're behind the curve. you're assuming that hard practices are the answer. It's not always the case. One barnyard in an area one concrete barnyard job or project might reduce a bunch of phosphorus, but that only may be 5% of the load and cost you $250,000. What if that $250,000 was spent somewhere else, changing the minds and getting people to think like that younger farmer? That's how you're going to solve it. That younger farmer we talked about up there in Athens, by going to no-till and cover crops on his 5,000 acres, he saves him money, but it also stopped about 3,200 pounds of phosphorus from getting into the Wisconsin River down to Petenwell and Castle Rock and all the way down the system. That's not counting nitrogen. That's just the phosphorus load. That's how we're going to get things done, folks. And you get that again by you got to think holistically. If you look at it just at your shoreline, it's not going to happen. You're in a reactive mode, not in a proactive mode. You got to have innovation. If it was done in the past, great. But I had a supervisor once tell me, and when I was in a different program, said that if you're doing the same thing you did 15 years ago, you're probably doing it wrong. And that could be technology's keeping up, or technology surpassing how fast we are adjusting to it, how we can use it. And B, to get aquacentric. I don't know if it's a word or not. I just created it the other day. But if you think it's just me and my water, that's not going to happen. You're missing the big picture. And again, the big picture is the watershed. It's not just the water, it's the land. And this is what you get over here to the right from your water resources specialist or engineer if you think you're just going to do this at the waterfront. So that's about it. But before we go, we got a quick sports quiz. You can answer these questions in the chat or whatever. Where does water quality start? What's the best approach? And how do we address the NPS challenges? So here are the answers. Where does water quality start? It's on the land. What's the best approach? Holistic thinking, thinking big, thinking basin-wide, might be practicing at a smaller scale or county-wide scale or political boundaries, but you're thinking basin-wide. And how do we address NPS challenges? You do that with people. That's how you get implementation. So you can have all the science in the world, all the great engineers like Oldie out there, but at the end of the day, you need people in implementation to make that happen, to bring soil health into a reality. So we increase our quality of the land that's our water's draining through and getting into the lakes and streams. So with that, that's what I got. That's it, folks.
All right. Thank you, Pat and Scott, for those presentations. We've got about 7 minutes here for questions. So if anybody has any, please go ahead and type those in the Q&A box. We did have one that's come in and it looks like it has a lot of support behind it. So question, how do you convince riparian owners that long-term solutions are better than short-term solutions? For example, taking out algae.
Do you mean like how not to be reactive and versus being proactive? Like don't treat the algae, look for the source. Is that the idea of the question?
I would guess, Scott, I think they're probably looking at their neighbors who are seeing the algae as a problem and are just going about, I'm just going to scoop it out, versus thinking, what can we do in the long term so that 5-10 years down the road, we don't have these issues.
Yeah, it'd be analogous to, putting a Band-Aid on a gaping wound. If you got an algae bloom or something, yeah, I can go out there and kill it. I can apply a algicide to it and release everything, all the phosphorus and everything that was tied into those cells, so it just recirculates again in 2 more weeks. Or I could go up into the watershed and stuff.
Okay. Another question came in. What are your thoughts on how drain management and floodplain reconnection can help address erosion and nutrients? Big opportunity or not sure?
That's going to be situational dependent. And I think it does play a role. but it's kind of one of those things where we think about where does it fall in the hierarchy of things that need to get done. And again, if you've got excessive runoff, doing some of those things for the drainage management may not be as helpful as if you first control, kind of stop the bleeding and control what's coming off the landscape. But again, it's going to be, it's a very different question if you're asking that in the Central Sands versus, the Marathon County or Sauk County, that sort of thing. So it is situational dependent about, the importance of those practices along the stream corridors. I mean, they do a lot for, definitely do a lot for habitat. There's things that we can and should be doing in terms of stream stabilization just for the habitat benefits. But, when we get day in and day out, we really want to kind of make sure we protect those investments by, doing what we can to help that hydrology act a little better on the landscape.
Thanks, Pat. We lost Scott, but hopefully he'll come back on here. We still have a few more minutes, so if anybody wants to add some additional questions into the Q&A, please do so. There are a couple things that I thought maybe would help maybe people who are struggling with some watershed issues or just starting to think about that watershed approach. You had some really great water quality data that you could share with us, Pat, from what was going on with the Wisconsin River and how it in turn is improving water quality, Secchi, and other things within Petenwell and Castle Rock. You were working through that by TMDL. If there's another group who is interested, I mean, who gets a TMDL going? Is that something that can start from a community-led support, or is that something that starts with the county or the DNR?
Well, it can be any one of them. One question is, I mean, we have a number of TMDLs in the state. Roughly, we got about 50% of the state is covered by one form of TMDL or another. Most of these deal with phosphorus and suspended solids. So if you're in one of those areas, the first thing I would recommend doing is reach out to your local, DNR water quality biologists, and they can help you. And then, because then I think you really get into the next phase that Scott was referring to, things like a 9-key element plan, where we're really taking that TMDL, which is a kind of a what sort of thing, like how many pounds, or, but it doesn't really get you to the, well, how do we get that reduction? And that's really where those local planning efforts come in and are so, critically important. And, working with DNR, the county, people on the water, in the watershed, and really coming up with a good plan that can kind of get you all to where you want to be. That's really what we need there. If you're kind of outside those areas, the one thing I would, I guess, say is the question comes back to, is a TMDL the right tool? A TMDL does some things that are really good, and that's that what part. But unless you have a lot of wastewater point source type issues, you still need to get to that 9-key element plan and that locally led planning effort. And you can do that without the TMDL, and DNR will support you in those efforts. We have a number of these 9-key element plans that we've developed outside of TMDL areas. It means a little bit more work on the front end to try to figure out, how much reduction is needed for water quality goals and things like that. But again, that's something that, the department can help you with, and, it's something we can also fund through our grant programs. But yeah, I think, for a lot of places in the state that aren't currently covered by a TMDL, jumping to that 9-key element plan and really trying to figure out, either through the lake planning process or something similar, really trying to figure out what you're going to do and, how you're going to get it done is really the key step. And, those locally led efforts are always going to be more successful than something, coming out from DNR, I guess I'll say. So we really need that community support to make these things happen at the local scale.
Perfect. Thanks, Pat. One more question here before we wrap up our session. How much does goose poop play on nutrient loading? Is it a major contributor?
You want that one, Pat? Can you hear me or not? No.
Yeah, go ahead.
Okay. Unfortunately for the guests, I am back online here. It all depends on your nutrient load coming in. If your nutrient load coming in is super high in phosphorus and you don't have much as far as if the goose poop is not a big factor of that, it's insignificant. So, looking at your nutrient budget tells you where you got to control your sources. Most cases, we can calculate, actually get an idea of how much phosphorus is released by how many geese are on the proper or on a body of water, but you're making some major assumptions that often aren't true. You're making an assumption that 100% of their stuff gets into the water. They usually don't poop in the water. They like to do that on the land. Yes, it can drain into the sand, into the shoreline and into the groundwater that way. But when phosphorus goes through the soil, it likes to bind up with a lot of cations or a lot of stuff like iron and magnesium that's in the soil naturally. So, but your nitrogen can still get in there because usually bird poop is mostly ammonia. So, it's an inorganic form, but if the plants don't snap it up, then something will get in there. But most cases, if you're worried about geese, it's for bacterial control. Sorry, you're not going to get a big reduction in phosphorus on most lakes with a large watershed. If you looked at Petenwell and you're worried about geese, it's immaterial. If you're looking at a smaller system upstream like Big Rocky Cree or something like that, that's a 200, 300 acre lake, but a gigantic watershed, like, 14 mile, Big Rocky Cree, Friendship Mill Pond, all those, it's a drop in a bucket to what you need to get done out there. Again, that gets back to that point of sticking all your money into one issue when you can use that money to have a bigger impact up in the watershed someplace else.
All right. Thank you, Scott. All right. With that, we have run out of time for our session today. Thank you for joining us. We have a 45-minute break now for lunch, and then the next session will begin at 1:15. It'll tie in nicely with what Scott was talking about with reaching out to the people within the watershed and creating those partners, as we will be talking with the folks from Petenwell and Castle Rock and the Eau Plaine watershed and how they made partners with folks across their watershed, including those farmers. So please join us back at 1:15. Thank you.